In the previous video, we created a basic CSS transition using transition property and transition duration. But there are still enhancements to be made. So let's get a little more in depth by defining properties for easing and delaying transitions. We'll also cover a more intricate method for creating custom easing functions with cubic Bezier curves.
In the HTML file, I've added a containing div around box and gave it the class wrap. And I'm back in the Chrome browser as version 26 and above supports transitions unprefixed. We'll again trigger our transition on hover, but this time the transition on box will happen when we hover over any part of this wrap container. So let's go ahead and create our CSS for this. In our CSS file, we'll create a descendant selector using the hover pseudo class on the wrap selector, followed by a space and our box selector. So let's create a new transition using the margin left property, where we'll increase it to 75%. So now we want the margin and background to transition on hover. So in our box rule, let's again add a transition duration, and we'll make it 1 second. So we'll save this, we'll refresh the browser, and now our transition happens in 1 second when we hover over the wrap element. The speed of our transition can vary over its duration. It actually follows an acceleration curve that has a set of time intervals. We can either create our own custom intervals or use one of the predefined timing functions. For example, with the transition timing function property, we can establish an accelerated curve. The values in this property determine what happens in between the beginning and end of a transition. We can increase or slow down the transition speed and its duration. So there are 8 predefined timing functions. So let's go over some common ones. Back in our CSS, we will first define the transition timing function property. So let's try the value ease, which is actually the default value. So the value ease starts gently, then it speeds up, as we can see here. With the value linear, the transition maintains a linear motion, so it's at a constant speed with no easing. The value ease in starts slow, then speeds up until the end. Ease out is the opposite of ease in, which starts at a constant speed, then slows down at the end. The value ease in out starts slow, speeds up, then slows down. Now we also have the values step start and step end, and we also have steps where we can actually define the number of steps followed by the value end or start. So here we'll just give it end. We'll save this, and when we refresh, we can see how it transitions and the number of steps we defined until it ends. So here we defined 4 steps, so the transition happens in 4 steps before it reaches the end. Now, these timing function values are all mapped to cubic Bezier values. As I mentioned earlier, for more complex timing functions, we can customize our own by specifying points along a cubic Bezier curve. It's a mathematical function that provides a smooth curve that accelerates and decelerates. So the curve is defined by 4 control points, P0 to P3. And graphically, they'd look like this. So P0 and P3 are always in the same spot. Point 0 is at 0, 0, and point 3 is at 1, 1. So it starts at point 0, going towards point 1, and arrives at point 3, coming from the direction of point 2. So P1 and P2 are the points we determine to provide the directional information. So it's sort of like using the Bezier curves and vector tools like Illustrator. We create these Bezier points with the pen tool and drag the handles at certain points to create shapes. With the cubic Bezier function, we set the values for P1 and P2, and they're each specified by an x and y value. Both x values need to be in a range between 0 and 1, otherwise it's invalid. The y values can break out of that range and go beyond 1 or below 0 using a negative value. So back in our CSS, let's go ahead and define these control points in our cubic Bezier function. So first, the x value for point 1 will be 0.5, and we will make the y value for point 1 0, and the x value for point 2 will be 0.3, and finally the y value for point 2 will be 1. So we'll go ahead and save this, and when we review it in the browser and refresh the page, we can see how it quickly eases out, then slowly settles in. In our style sheet, if we change our y values, so for example, the y value for point 1, we'll make it negative 0.5, and the y value for point 2 will be 1.3. So we're going below and above that 0 to 1 range. So we'll save this, and we'll refresh the browser. So now we'll see how it eases and breaks out of the wrap element with a sort of bounce effect. Then it eases back into its end position in the same way. So this is a slightly more realistic effect. Finally, we can create a delay that happens before the transition begins. All we need to do is specify when the transition should start with the transition delay property. So we'll go ahead and specify a transition delay of 1 second. And we'll save this. When we view it in the browser and hover over wrap, we'll see how the browser will wait 1 second before it begins our transition. We can also delay the transition properties individually. So for example, back in our style sheet, in our box rule, I will add the transition property value, followed by margin and background. And below this, I will go ahead and add a transition duration of 0.6 seconds that will be applied to our background property. And I will also give our background property a timing function of ease, while margin maintains our cubic Bezier function here. And I will give the margin a delay of 0. So now our background transition will be delayed by 1 second. So we'll save this. And when we refresh the browser and hover over wrap, we'll see how the background is delayed by 1 second. Meanwhile, the margin transition happens right away. Now we can combine these into one simple declaration with the transition shorthand. So this is the shorthand property for all of the transition properties we've just covered. And the order in the shorthand is important because the second time value declared will always be considered the transition delay. So for example, we'll go ahead and specify our first transition for margin. So this is the 1 second duration, followed by the cubic Bezier value. We just go ahead and paste that in. And the second time value of 0 seconds will always be the delay. So any time value that follows this duration will always be considered the delay value. So let's go ahead and keep that in mind. Then we'll use a comma, and then we'll specify the background property, and we'll include the 0.6 second duration value for that, followed by the ease timing function, and finally the 1 second delay. And now we can go ahead and get rid of these individual properties up here. And finally, let's go ahead and include the vendor prefixed properties for Safari and the older versions of WebKit, Chrome, Firefox, and Opera.
There are many helpful tools out there for creating cubic Bezier curves. For example, cubicbezier.com, developed by Leah Veru, is a simple app for creating, testing, and comparing easing functions. The neat thing is that it does not restrict the coordinates to the 0 to 1 range, so we can easily create those bouncing transition effects. We then export the CSS or copy and paste it into our style sheet. The Caesar easing animation tool is another good one that produces code snippets. We simply choose an easing type, preview it, and customize our curve until the movement is just right. If a browser does not support CSS transitions, it will simply apply the value instantly without any animation. This is usually fine, since transitions should be used mainly as an enhancement feature. The content, functionality, and overall experience should never hinge on the transition effects.